Okay, so today is 7.2, day 2. Yesterday we really focused on arithmetic sequences. Today we're going to focus on series. And what a series is, it's just really the sum of the terms of an arithmetic sequence. And given an arithmetic sequence that has a first term and a common difference, then we can sum up the terms there. So we have two formulas. The first formula you'll use if you know the first and last term. Okay, and that is S sub n. What that means is the sum of the first n terms. Okay, so it's the sum of the first n terms, however many terms you're going to have. Okay, and that is equal to n over 2 times the addition of your first term and your nth term. Now, if we know the first term and the common difference, okay, so we don't know the last term anymore, here's our formula that we're going to use. Where this comes from is, since I don't know the last term, we know that a sub n is also equal to a sub 1 plus n minus 1 times d. So what happened there is this gets inserted into the a sub n spot here, which then, here's your two a1 or a sub 1s, and then there's your n minus 1 times d. So again, we're summing up a sequence. That is what an arithmetic series is. Okay? But again, the key, if it's arithmetic, we have to have that common difference. So the first problem says evaluate S sub 21, which is the sum of the first 21 terms in this sequence. You'll notice they give us the sequence 48, 44, 40, 36. If I really wanted to, we could keep going all the way through all 21 and add them all up. But we have our formula that's going to help us out a little bit more here. So let's think about what we have. We know that 48 is our first term. We don't know the last term, but if you notice, we keep going down 4. So we know that a sub 1 is 48, which, since we're going down 4, your common difference would be negative 4. So we know first term and common difference. We're going to use that second formula. So S sub 21. Now your n is right there. That's the 21 over 2 times 2 times 48 plus 21 minus 1 times a negative 4. So inside we have 2 times 48 plus 20. Make sure you have parentheses there, so you make sure you multiply that times a negative 4. So I have 16 on the inside. 21 over 2 times 16. And we see that this sums to 168. Okay, so the sum of those first 21 terms is 168. Now, you see that answer 168, you might be thinking, wait, if I add those first 4 terms, that adds to 168. But if you think about it, if we go through 21 terms, eventually we're going to end up with negative terms. Okay, eventually going to get down to 0, then negative 4, negative 8. Okay, so some of you might have thought, like, wait, that 168 seems a little weird. Now, those first 4 numbers add to that. But this sequence does eventually end up with negative numbers at the end. Okay. Number 2, find the sum of the first 200 positive integers. Okay, well, n is going to be 200. The first positive integer would be 1. And then the 200th would be 200. And so we know our first and last term. So we can use that first equation, first formula. S sub 200 is equal to 200 divided by 2. And then first term plus last term. So we have 201 times 100. We see that the sum of these terms is 2,000 or 20,100. So a little bit more straightforward on that one, knowing that first and last term. Okay, the third one, find the first term and the common difference. Ooh, so we don't have either. What we have is the sum of the first 25 terms in this sequence, and then we have the 25th term. So we need to either find the first term or the common difference before we can go anywhere with this. So if you think about that first equation, S sub n, we could do S sub 25 is equal to n over 2 times the first term plus the 25th term. Well, we can use that. We know that the sum is 650. We know we have 25 terms. We don't know the first term, but we do know the 25th term. So we can use that to solve. So we can start by taking that 650 and multiplying by the reciprocals of 2 over 25. We see that 52 equals the first term plus 62. Subtract that over, we find out that the first term in this sequence would be negative 10. Now that's okay. You can have a negative first term. Okay. Now that we have our first term, we can use this to find our common difference. Okay, and you have a couple ways you could do this. Okay, you could go plug it back in the formula, or think about, we have these terms, we can do our slope formula that we were kind of using earlier, where the common difference is, okay, we got 62 minus a negative 10 over 25th term minus 1. So 72 over 24, or that just comes out to be 3. So as you work these problems, don't forget about some of the earlier things that we did learn about how these formulas work together. Okay, 2 more problems here. So we have not talked about this yet. You might have seen this before. This is sigma notation, and this is just still summation. So this is your sigma right here. It's capital E, Greek letter. Okay, and this is telling you to sum up a sequence. So what it means is, I'm going to start with I equals 1. Okay, so I'm going to plug in a 1 for I. So it'd be negative 1. That's my first term. Then I'm going to sum that with the next term. So I is 2. So I plug in a 2. So it would be plus a negative 2. And then plus a negative 3. And this goes on until we get to I is 100. So plus a negative 100. That is what is going on in this process. I will also put onto Schoology a quick video that shows you how to actually type in this whole thing right here and do it really quickly for you, both on the 84 and the 89. But we can turn this into be what we did above. Okay, where S sub n, think about it, we know our first and last term. Okay, so we're going to use our n over 2 times a sub 1 plus a sub n. And we have 100 terms. Okay, so 100 over 2. The first term's negative 1, and then it's negative 100 as our last term. So we get negative 101 times 50. We see that this sums to negative 5,050. You will actually see this summation formula quite a bit, especially if you continue on into math in college. In calculus, you see a lot with sequences and series. So this will be pretty important notation to understand. And then for the last one here, again, this is saying, here's our sequence, 5i minus 9. I start by plugging in a 1. Okay, then plus whatever I get for plugging in a 2 into for I, and go all the way through for the first 15 terms. Well, we know that we're going to have 15 terms. We can find the first term, it would be 5 times 1 minus 9, so negative 4. We can find the 15th term. 5 times 15 minus 9. And we get 66. And now we can just use our regular formula there. So the sum of the first 15 terms is 15 over 2 times the first and last term added together. So the first and last term added together is 62 there for us, times 15 over 2. And that gives us 465. So I will post a link so you guys can also learn how to do that in your calculator, and it actually makes it really quick.